It's my pleasure to present this keynote talk on maintenance in an Industry 4.0 and COVID-19 world, the case for remote operations. This talk focuses on how maintenance is being refactored due to advances associated with Industry 4.0 and how the need to work remotely, brought on by the COVID crisis, is accelerating the adoption of new technology and processes in maintenance. Who listening remembers the introduction of Industry 3.0 technology, when we first put logic processes and information technology into our factories and plants? The first plants I ever operated had start and stop buttons next to all the motors and almost no process control. That was 30 years ago. Now I'm watching as Industry 4.0 unfolds. From a technical perspective, the industrial internet is a new type of industrial digital system that integrates decision support, IT and OT systems. We're connecting people, machines, objects, and other production-related assets on an extensive scale, and we can perform processing, modeling, and analysis of massive industrial data using the cloud and other digital platforms. A less appreciated feature, but one that I shall focus on in this talk, is the ability of this same technology suite to support remote operations of your plants and factories. A need you may not have considered a year ago, but one that is front of mind as we try to keep businesses operating during the COVID pandemic. Here is a world map, one now quite familiar to many of us who look at the Johns Hopkins COVID website. You can see Perth in the lower right-hand corner. Perth has a population of 2 million, is the capital of the state of Western Australia. And why are we interested in it? Well, the West Australian economy, unlike most other economies, is expected to grow by 1.25% in the 2020 to 2021 year through the COVID crisis. This is at a time when governments elsewhere in Australia and around the world are seeing record budget declines and deficits. So what is it about West Australia that has allowed for this positive economic growth in spite of the COVID crisis? And how does it relate to maintenance and remote operations? Well, did you know that WA is a world leader in remote operations? We hear a lot about exciting developments in automation in Germany, China and Japan, but quietly and a long way away from Europe and the US, a digital revolution has been underway in Western Australia over the last decade. This capability has been driven by clear business value drivers for improved safety, health, personnel retention and productivity. To understand more about this story, you need to understand something about the geology of Western Australia. WA has the world's largest iron ore reserves. Iron ore is used for making steel, and steel is an essential element in building modern infrastructure. However, the iron ore mines are in a region called the Pilbara, which is more than 1,200 kilometres from West Australia's only major city, Perth. The Pilbara is a very challenging place to work. In the summer, temperatures often exceed 40 degrees C. It's very dry, except during cyclone season, when it can be very wet. Distances between the towns are huge and it is sparsely populated. The vast majority of workers are FIFO, fly in and fly out, and they live in accommodation such as shown here in the top left. Because of the harsh conditions, pay rates are high, as are accommodation and travel costs. People would much prefer to live in Perth, a city bounded by the Swan River and the Indian Ocean, which is quite lovely, as you can see from the photos in the bottom left. In 2010, Rio Tinto, one of the major iron ore miners, opened a digital hub, an operations centre to control its rail, infrastructure and port operations from Perth, shown on the map here at about Portugal, whereas as you can see the Pilbara is right up somewhere around Southern Ireland. This resulted in a mass relocation of many hundreds of its staff from the Pilbara back to Perth. Over the following decade, other iron ore miners have built similar remote operation centres. These have had many benefits, most notably safety and health, particularly mental health, productivity and costs. There are still FIFO workers, but many less than previously. So what do we mean by remote operations? Remote operations is the ability to monitor and control things over vast different distances, often in harsh or high-risk environments. It comprises all the technology, people and processes required to be connected remotely. Examples include autonomous fleets of trucks on remote mine sites, subsea equipment in oil and gas, and managing life support equipment in space. Did you know that Western Australia has the world's largest robots? These include the fully autonomous heavy haulage train you see in the top left of this picture. This one is 2.4 kilometres long and hauls iron ore 800 kilometres, a 40-hour journey. Western Australia also has a significant proportion of the world's fleet of autonomous dump trucks. These are the size of a double-storey house on wheels and can travel at 60 kilometres an hour without a driver. In one mining company, FMG, their autonomous trucks have travelled more than 47 million kilometres and moved 1.4 billion tonnes of material. Note, this is twice as far as autonomous cars from Waymo, owned by Google, that we hear much more about. One very important part of automation has been the development of integrated remote operations centres based here in Perth. There are now 4. In the next section, I'm going to show you a short 5-minute video about the design of one of these integrated operations centres. And as you watch it, I want you to think about the opportunities for radically rethinking maintenance when you have a digital platform like this in place.
The scope of operations at Roy Hill, we have a mine up in the Pilbara, which is one of the largest mines in iron ore. Located at the mine, we also have a processing plant, and from there we have a 344 kilometre railway that takes the product through to our port operation, where we load it onto ships at Port Hedland. So our mining operation is one of the largest in iron ore. We have an ore reserve of approximately 2.3 billion tonnes of ore. We'll mine that at approximately 1 million tonnes a day and feed approximately 73 million tonnes per annum into our crushing facilities, which then gets turned into 55 million tonnes per annum of iron ore product.
So when Roy Hill first began, we had the opportunity with a blank piece of paper to really design the operations from scratch. And one of the things that Barry, our CEO, and a couple of the early members of the team were very passionate about was building an integrated operating model.
It enabled us to rethink how is it that we would run an end-to-end mining business and do that in a way that has never been realised before.
They really needed a solution that provided overall end-to-end visibility of their entire value chain, where they make their money from pit all the way to the port.
We always jointly focused on the right outcome. We came together to the table and we solved very complex problems as a team, and as a result we have a very successful outcome and product.
Remote Operations Centre is located about 1,300 kilometres away from our mining operation, and our port's a bit further than that. Even with all of that distance, we're still controlling all aspects of the operation.
Roy Hill has put a lot of thought into how their people collaborate, how they make sure that they make the best decisions, how they make sure that they have the right information in the hands of their people.
In terms of how we've laid out the Remote Operations Centre, from the very right-hand side of it is where we control the mine, and then if you move across to the left, there's a fairly logical progression towards the port. So effectively, from right to left in the room follows the production chain from end to end. The other arrangement in terms of from front to back is really around time. So the further away you are from the action, the further back in the room you sit.
People can collaborate effectively because they sit right next to each other. Underneath that, we see a technology landscape that meets that same model, so that if we have people collaborating on a day-to-day basis, we're also providing them with all the right information to enrich the conversation even further.
In reality, all it means is that rather than operating in silos, such as port, rail, we operate across the business. so important in automation and where we start to use technology, because you're less reliant on structures like hierarchy. You're more reliant on how you collaborate with each other to get the job done.
The way that we collaborate and the way that we solve problems together, I think, creates a unique culture that I haven't seen at other organisations before.
The reason why the technologies are essential is because machine learning, AI, VR, augmented reality, the digital twin is what enables our people to focus on more value-added work rather than repetitive work. And one of our vision statements is that we want people to realise their full potential. So it is about being a high-performing business, but it's also about people realising their full potential.
We really want to provide technology that frees people up so that they can do the real leadership, so they can be in the field talking to their people and understanding what's going on, not spending all their time shuffling paperwork and finding data. And I think that then gives them the opportunity to think and to provide real value, and then we're going to be performing at our best. And I think in that kind of environment, it's a much more engaged workforce, which really gives us the opportunity to say that we're really caring about the way that we're doing work and not just the work that's getting done.
Trying to empower those people to fulfill their full potential. That's what Roy Hill sought to achieve when they started out. Now, as they continue on in the journey into the future, still the core emphasis and one of the core values of their company.
So let's explore for a minute what these platforms enable in terms of maintenance changes. As you can imagine, if you're operating equipment 1,500 kilometers away and hope to have only minimal people on site, then you can't afford to have lots of unexpected failures. The consequences in terms of costs and downtime will rise very quickly. This figure conceptualizes maintenance performance as 4 discrete states associated with organizational behavior around maintenance management. Many manufacturing and process operations still oscillate between the planned and reactive states shown in the left. For many sectors, it has proved difficult to get to and stay in the reliability state. In the reliability state, there are few or no unexpected failures. Asset operators know the capabilities of their systems, and they have appropriate maintenance strategies in place that address real failure modes. And they execute these strategies on a schedule, taking into account short and long-term considerations. This means there is organizational discipline and control. Now we're going to talk about work management. The work management process is at the heart of maintenance. It is where value is delivered, when the right maintenance is done at the right time, and where value is lost or destroyed when maintenance is not done when it should have been, or is executed at the wrong time. You can see the work management process involves 6 steps shown in the yellow box at the bottom of the slide. Each of these is vitally important. Along the top of the slide, you can see how maintenance work is identified. Traditionally, this has been done from having maintenance strategies in place. In the purple box, we call this structured work. And also when equipment function has already deteriorated or failed, called corrective work. To this, we add another box associated with Industry 4.0 developments, which is work from predictive maintenance analytics groups. As you can see, considerable work goes into deciding what work to do and when to do it. A number of sessions at this and other reliability conferences and many consulting hours are spent building mathematical models used in the structured and analytics work identification boxes. Examples include machine learning for fault detection, prediction of end-of-life events, anomaly detection, optimization intervals, and so on. However, in my observation, it is rare to find much work and focus dealing with the reality of work management as experienced weekly by maintenance planners, schedulers, and operations staff. As I said earlier, remote operations needs good work management practices. Think about the ultimate in remote operations, operating in space. Ask yourself, would you do a spacewalk without a detailed plan and a carefully scripted schedule? As we have moved to integrated remote operations centres here in Perth, we've had to pay a lot more attention to maintenance planning and scheduling. How many of you working in predictive maintenance analytics have read this planning and scheduling handbook, now in its 4th edition, to understand what happens to the work orders resulting from your analysis work. Note that the book is 900 pages long. In my opinion, the research and analytics communities should pay far closer attention to the planning and scheduling needs of industry, as it is only in the execution of work that value is actually delivered through the restoration of function of the machines so they have productive capacity. Scheduling is a key part of efficient execution. However, scheduling is a challenge in any moderately complex operation, more so in continuously operating facilities like process plants than in batch or fleet operations. All work in maintenance is associated with a work order. Consider maintenance work as being like a tank, which is constantly being filled up with work orders you want to do, from structured and predictive work, and work orders you really don't want to be doing, associated with unexpected loss of function or capacity, corrective work. You always have a backlog of outstanding work. Scheduling is like a valve on the output of this tank. It is your control on the maintenance work that you execute. Schedule too little, and the level of the outstanding work rises. If you're a mature organisation, then all of your work orders will be risk ranked, and you will know each of your equipment's criticality rating. You will also have a significant number of structured work orders. This is work associated with maintenance strategies such as inspections and fixed intervals strategies. These are all inputs to the scheduling process. On top of this, we are increasingly seeing work orders resulting from predictive analytics work. These predictions are problematic for schedulers, as they are based on models and therefore have inherent uncertainty. Often, this uncertainty is not clearly quantified or conveyed. Many plants schedule at least 2 weeks out, meaning that work that comes in during the week after the schedule is decided, but before it is executed, is regarded as unscheduled. This requirement to make predictions early enough to get on the schedule increases the uncertainty bounds. As a result, schedulers can be reluctant to schedule work associated with these predictive analyses and are over ready to defer this work when they are resource constrained. I believe it is one of our jobs as researchers to help reduce the uncertainty in the equipment condition estimates so that we do the right work and we schedule it at the right time. Our models should be able to help by advising not just when to do work, but when not to do work. Over-maintaining is particularly expensive in remote operations as you're doing unnecessary work. Likewise, we need to understand the factors that affect when work can be done, such as asset availability windows, so that we can help schedulers to get the right work done at the right time, where right is right for the health of the equipment, the likelihood and consequence of failure, and allows for execution in a scheduled availability window. Doing work that sits in the red boxes on the screen when you have remote operations is particularly costly and can destroy value. 3 years ago, in 2017, BHP, the world's largest mining company, reported spending $3.5 billion a year on maintenance of plant and equipment. That same year, they established a Maintenance Centre of Excellence, MCOE, with the goal of saving an aggregated $1.2 billion in maintenance costs across BHP by the end of financial year 2020 and reducing downtime by 20%. This is a really massive goal. Key components of the strategy include excellence in planning and scheduling and on optimizing maintenance strategies. The home centre of MCOE is in Brisbane. Brisbane, like Perth, is in the top 20 of the world's most livable cities. Many planners and schedulers working for BHP are now based in Brisbane, and they do forward planning for the iron ore, mines, rails and plant operations some 3,560 kilometres away. So what happened during COVID? With all of this digital infrastructure and remote operations processes and capabilities in place, what happened to the iron ore operations? You can see some data on the slide. First, note the West Australian economy grew a most impressive 1.1%. The WA iron ore producers have exported a near record 851 million tonnes in 2019-20. In West Australia, there have been 9 COVID-related deaths and 711 cases for a population of 2.6 million people. The WA state government locked state borders on the 5th of April, and they are still locked. It's immensely difficult to get permission to travel in or out of the state, and those few who get permission have to do 2 weeks mandatory hotel quarantine. In fact, WA now has a labour shortage with 17,000 vacancies as of August 2020. Our schools opened in late April, and now everything inside West Australia is open. So what did the iron ore producers do when COVID struck? So first, they sent everybody they could home, retaining only essential staffs on the mine sites. They created separate redundant ABE teams for their remote operations centres in Perth and also for their offices in Brisbane. They implemented mandatory quarantine and health checks, but otherwise it was business as usual with employees working from home. As of this month, November, some employees have returned to offices full-time, but many have chosen new working from home arrangements. The iron ore producers' ability to produce these sorts of outstanding results is not a fluke. Yes, they have been helped by the quick and decisive action of the West Australian government in isolating West Australia, but they also had the digital systems and platforms in place and the capabilities to use them to work remotely. This is a journey that has taken nearly a decade of investment and development, and I think it should be recognised and celebrated. So where to from here? Recognising the opportunities presented by the Industry 4.0 capabilities that are embedded in the digital platforms that support these remote operation centres, a number of the mining companies came together in 2019 to launch the Centre for Transforming Maintenance through Data Science. This 5-year centre is a partnership between the Australian Government, 3 mining organisations, BHP, Roy Hill and Alcoa, 3 research bodies, Curtin UWA and CSIRO, Core Innovation and MRIWA, the West Australian Minerals Research Body. So the title does not flow off the tongue, but it clearly states what we aim to do. For those interested, we have a great website. I encourage you to check it out at maintenance.org.au. So what are our focus areas? We've been very strategic in where we're focusing our efforts and want to leverage the platforms and processes already in place at our industry partners that I have described earlier. First and foremost, we're looking at real industrial data and use cases. This is so important. Industry problems are not usually presented in a nice, structured academic way with clean data, unambiguous response variables, and clearly defined constraints. In the scheduling area, we have to deal with thousands of work orders and hundreds of pieces of equipment, multiple crews, different trades, and numerous restricted equipment availability windows. The high dimensionality and combinatorial complexity quickly get out of control. Hence, we're working on new decomposition methods and optimization algorithms to handle this. Another area is in the recognition of the vast amount of technical knowledge locked up in unstructured texts. Think of maintenance work orders, maintenance procedures, defect elimination reports, condition monitoring reports, and the list goes on. At present, a huge amount of transactional work is necessary to manually read, interpret, and action steps in the work management process. We are working to make unstructured industrial texts machine readable and to apply reasoning to answer complex queries. We call this area technical language processing and work closely with a number of other international research groups. The iron ore operations I've described today are complex, dynamical, cyber-physical systems. We are using the mathematics of complex systems to quantify system properties from which we get advanced indications of changing system behavior. There are some very exciting developments coming out of this work. The decision to work with real industry problems and data is focusing our attention on what I call hard statistics. We often don't have clearly defined and consistent response variables. This is because in practice we have very few failures, and most of the events are not actual events, but potential events defined often inconsistently by an engineer or operator, or even worse sometimes, the event is not registered or recorded at all. As a result, cross-validation of predictive models is challenging. We also can't afford to make too many oversimplifying assumptions, like assuming as good as new repairs, or that operating conditions are constant, or that covariates are not time dependent. We often have way too much monitoring data and not nearly enough is useful for the models we wish to build. Finally, there are two other focus areas for our centre. The first is on ensuring models and processes can be transferred to our partners by use of appropriate architectures and codes. And secondly, in collaboration with we are collaborating with a group of organisational psychologists. McKinsey, a global consulting company, recently published a report stating that 70% of all maintenance transformations fail, mostly due to employee resistance and lack of change in leadership behaviours. We know this actually from our own past experience. Hence, in our centre, we're looking at how maintenance people can be supported to accept the outputs these new data-driven models provide and what the barriers to adoption are. So, are remote operations going to be the new normal for a post-COVID world? If so, you might want to keep an eye on what's going on here in the iron ore industry in Western Australia. I have talked about the developments over the past decade of the integrated remote operation centres and how they provide a platform for improved maintenance productivity and effectiveness. In closing, I want to share some exciting news about what's next. In 2020, AROSE, the Australian Remote Operations for Space and Earth, was formed with a vision for Australian firms to be the leading global providers of on and off Earth remote operations. Here is a 2-minute video that shows you how advances in reliable remote operations pioneered by our iron ore companies and researchers here in WA are informing exciting innovations for space, the next frontier. Finally, I'd like to make a number of thank yous. First, to the conference organisers who made this conference happen in the middle of the COVID crisis and during lockdowns in Italy. Colleagues and industry partners in the Centre for Transforming Maintenance Through Data Science, the UWA Natural Language Processing Technical Language Processing Group and the UWA System Health Lab, many international collaborators, and finally a personal thank you to the BHP Fellowship for Engineering for Remote Operations, which has so generously supported my work for the last 5 years. Best wishes and thank you.